Okay, so here it is. We'll go over this again. Take notes. This video is going to be in the shared folder. I'm just going to do it as a single file then instead of splitting it up. So you can watch this again later throughout the day or at home tonight, okay, when you're doing your corrections. All right, so the first thing, it says to put the capital letter in the blank to the left. Most people are doing that. That's fine. Some people are like not putting letters or putting lowercase. All right, so there were three different versions of the test, Form A, B, and C. I'm working off of Form A. You could see your form in the top left corner. So if you have a Form B or Form C, I'm going to be working the same problems. They're just in a different order. Make sense? So you can find them. All right, so on Form A, this is Q of 10. This is the function value. This is looking for the bridge, all right? So you're looking for the point. So you go to 10, and you look for the red dot, and there it is. It's on the x-axis, where y is equal to what? 0. So the answer is B, 0, okay? Function values are the dots. Look high, look low at 10 for the function value. This one is the general limit at 6. There's no plus or minus as an exponent, so you have to check both sides. Remember, the general limit only exists if both sides are approaching the same thing. So notice from the left-hand side of 6, the limit is 2. From the right-hand side of 6, the limit is 5. Does 2 equal 5? No. So even though the one-sided limits exist, and they're 2 and 5, the general limit doesn't exist because they're different. All right, so that one is E, D, and E. And of course, then you know what type of discontinuity we have based upon that. There's a jump. This is the right-sided limit at -2. Right-sided limit at -2. So here's -2. We need to approach from the right. Well, it looks like it's going up. This is where this piece was important. It said there's a vertical asymptote at -2. So you could assume that there's a dotted line there, and it's going to go up, up, up to where? Infinity, right, and that's answer choice B. Now notice we do have it defined at the vertical asymptote, and that's because this would be some kind of piecewise definition. All right, number 4, the limit from the left of -8. Left of -8, here's -8. We're looking for the limit from the left, so that's the road again. We hop on the graph, and we're getting closer and closer to the open circle, which is at -6, and that's answer choice B. There were a lot of B's and a lot of D's on this test, if you've noticed. All right, so that takes care of the graph. That's all we use the graph for. And now this one says the function p of x that has the property that the general limit as we approach 3 is undefined. Which of the following discontinuities can the graph have? Well, hopefully you were tipped off by this graph right here, yeah? If the general limit doesn't exist, it could happen one of two ways. It could be that we're approaching two different y values from both sides. The one-sided limits exist, but because they're not the same, the general limit is D and E. That would be if there was a jump discontinuity. Or it could be that we have a vertical asymptote at 3, and now the limit would be D and E because the y values go to either infinity or -infinity. And remember, when you say the limit is infinity or -infinity, you're saying first and foremost the limit does not exist, but now it's because the values increase or decrease without bound. So it would be also an infinite discontinuity, or VA. And then the other one that we've had was the whole. And remember, at the whole, the general limit does exist. There's only 2 times the general limit exists, at a whole and when the function's continuous. So the D and E is going to be just 2 and 3, and that's answer choice E. Okay? The general limit can fail to exist at a jump or a vertical asymptote. All right, number 6, simplify. So this was a good one. First of all, looking at this, does that 2/4 divide out to give you a half? No, we can only divide out common factors. And the 2 and the 4 are factors, but they're factors inside of terms in the numerator and denominator. So I did that as an answer choice to try and bait people. One person actually wrote on their test, yeah, it's got to be A or D because the 2/4 divide out. And I'm like, no, they don't. Okay? So let's go ahead and do the way we've been practicing. All the negative exponents go to the bottom. So that's x to the first. And then -3 all over x squared y to the first. And then over here we get 4y cubed all over x cubed. And then this one doesn't have any negative exponents, so I'll just put it over 1. All right, so that would be your first check on the quiz. Now, this is where some people are getting confused. They were asking me, how do we find the LCM? Well, first of all, LCM is also known as LCD, least common denominator. I like LCM because it's a little more descriptive. We're finding the least common multiple, but it's only of your denominators. So the numerators here do not have any say in what the LCM is. So you need a factor representative of each type, so we need an x and a y. And then in the denominators, we get the largest representative plus u exponent. So that's going to be an x cubed and a y to the first, right, of the highlighted one. We don't really care about 1 because it's the identity element. So there's your LCM over LCM. Now we carefully distribute, and when we do, we're left with 2. X cubed divided by x to the first leaves us x squared, and then y times y squared is y cubed. So there's your first term. Minus 3, if we distribute to the next one, x cubed divided by x squared leaves you an x, and your y's divide out, don't they? Y to the first divided by y to the first. So I'm not rewriting that thing. I'm factoring in behind each of those 4 terms, but I told you in class that you could do that if it helps you. Now on the bottom, we distribute this, and the x cubes divide out, leaving a 4. Y cubed times y is y to the 4th, and then plus 5. Nothing divides out because there's no denominator, so we just extend the party. We get more things. X to the 4th times x to the 3rd. What do we do with those exponents? We add them, so we get x to the 7th, and then y times y is y squared. And so that is answer choice. After carefully looking at all of them, it's answer choice B. So that's another type of problem, like my favorite problem, that we've been working a lot of. You should be getting these, okay, because you are practicing them on your own in the worksheet. And is it okay to do the worksheet more than once? Heck yeah. Do it, like, work it through it once. You're like, okay, I had to check the key. I had to get help. Now I'm going to go ahead and work it again on my own. Or you do that with the practice tests, okay, whatever. You need to be able to sit and do it on your own. All right, number 7. This is a piecewise function. So the easiest way to do a problem like this, when it says which of the following is not true, is just to go through each answer choice and see if it's true or not. So is it true that f of negative 4 equals 0? Well, this is an x value, right? Which piece do we use when x is negative 4? Well, negative 4 is less than negative 3, right? So we're going to use the top piece. So you only plug it into the top piece. If you plug a negative 4 in there, you get negative 4 times negative 2 is positive 8, and 8 minus 8 is 0. So that's correct. All right? You only use the x value in the piece where it's defined. If that had been x of positive 4, we would have used the bottom piece, because positive 4 is greater than negative 3. All right, so that's the correct answer. So it's not, I mean, that is true, so it's not the correct answer. What is the limit from the left of negative 3? From the left of negative 3. Well, negative 3 is where it exchanges, and remember, left of is less than. So we'll plug that negative 3 into that same top piece. Negative 3 times negative 2 is 6. 6 minus 8 is negative 2. That's also correct. What would be the limit from the right of negative 3? Well, that would be the bottom piece. Remember, right of is greater than. So right of negative 3, by direct substitution, you get 9 minus 11, which is negative 2. Now, just for kicks and giggles, it's not part of this question, but because the limit from the left of negative 3 and the limit from the right of negative 3 are the same thing, and they're both negative 2, what can we say about the general limit at negative 3? It's also negative 2. Yeah, it's also negative 2. So it's looking something like this. I'll draw it. Here's x equals negative 3. And we're coming in looking something like this. There's the open circle at y equals negative 2. And what is the function value of negative 3? I didn't ask you that. But notice neither one of the inequalities have an equal sign. The equal sign is in the middle. It says when x is negative 3, let y equal 4. And so that would be somewhere up here. So what type of discontinuity now do we have? Is that a jump? No, it's not a jump. Remember, a jump is defined when the left-sided limit and the right-sided limit go to two separate y values. I even said in class, just because when you're sketching it from left to right, you have to jump up to plot the 4 and jump back down, that's using jump as just a regular old verb, not as a vocabulary word. This is still a hole because it is removable, right? I could plug that hole and make it continuous. So that is a hole, whether or not the function is defined at 4 or not. So D is obviously now the wrong answer. There is not a jump at -3. There is a hole. And by the way, the hole is at -3 comma what? Is it -3 comma -2 or -3 comma 4? The hole. -3 comma -2, right? The function value is 4, but the hole is the open circle. All right, and then I guess the domain is all real numbers, and it is. We have the two pieces made up of polynomials, so they're continuous everywhere. And then notice it's defined to the left of -3, to the right of -3, and at -3. So it's defined everywhere, so that's true. Okay? So it's important that you can figure out what type of discontinuity we have based upon the limit in the function value information. All right, so that was a pretty good question. It required a lot of analysis. Finding the domain, okay, that was one almost identical to this on 2017's test. We have two radicals, two square roots, and a denominator. So let's go ahead and analyze them separately. The first one, I'll call it radical 1, or radicand 1. That's x squared minus 16. It has to be greater than or equal to 0. If you factor that, x minus 4, x plus 4, you know that that's a parabola that opens up, yes? So if you sketch it, here's -4, here's +4, and the parabola opens up. And now we want to know for what values of x is it greater than 0? Well, it's greater than 0 above the x-axis. It's equal to 0 on the x-axis, so it's going to be 4 and to the right and -4 and to the left. So I'm going to go ahead and say x is less than or equal to -4, or x is greater than or equal to +4. That's the disjoint set. It's one or the other, but not both. It's either to the left of -4 or to the right of -4. And that's why we write it as two separate disjoint inequalities. All right, let's do radicand number 2. That's just little old x, and it has to be greater than or equal to 0. So there's really nothing to solve there. And then we got the entire denominator, which is the square root of x, and then +2 cannot equal 0. Here's where some people messed up on the free response as well. Can we just like square it right here and call it x plus 2 cannot equal 0? Can I just get rid of the radical? No, I cannot do that. Okay, if you want to square it as it is, knock yourself out. But that does not give you x plus 4, does it? You would have to square, multiply, double square. You'd have to FOIL it out. You'll have a middle term that still has a radical in it. So that does not accomplish the goal. As I said in class, and it helps to kind of master those things because you practice them on a regular basis, you must isolate the radical first. You bring the two across. Now, at this point, you might say, hey, I'm not going to take the positive square root of something and get a negative. That's never going to happen. Okay, if you're thinking your way through the problems, that might occur to you. But let's say it doesn't. When you square both sides, you get x cannot equal +4. Now, remember, when you square both sides, it raises a red flag. You got to check. We are saying it causes a 0 in the denominator. Check it. If I plug a 4 in, I get the square root of 4, which is 2. 2 plus 2 is what? 4. It's not 0. So this one is extraneous. In other words, it does not cause a 0, and we do not want to exclude it. We apologize for the misidentification. Please don't file a civil lawsuit against us. All right, you're cleared. You're welcome to be in the domain. All right, so now I got to take the domain that works for everything. That says it has to be greater than or equal to 0. This says it has to be greater than or equal to 4 or less than -4. The way you could do this, if you think about a number line, here's x equals 0, is you shade. And you have to take the overlapping interval. That's one way to think about it. Hopefully you did number line graphs at some level. So where's the overlapping interval? X is greater than or equal to 4. That's one way to think about it. Or just say, okay, is everything that's greater than 0 also greater than 4? If I take this to be my domain, greater than 0, I could choose 1. Well, would 1 work in every piece? No, because this guy says I have to be bigger than 4. Okay, so you take the one that restricts more values. If something is greater than 4, it's also going to be greater than 0. Unfortunately, I don't get to use the negative part over here because is negative 4 greater than 0? It has to work everywhere. And so that's why x has to be greater than or equal to 4. That is your answer. And of course, if you threw out the 4 without checking it, that's answer choice E. But it doesn't cause a 0, all right? You have to choose the domain that works for everything. All right, and then the last one here, removal of point discontinuity. Kind of shocked at how few people remembered that. Remember, you could take your denominator here. It's a rational function. It's a polynomial over polynomial, and you could factor it. Factors of 24 that add up to 10, x plus 6, x plus 4. So we know that x cannot equal negative 6 and negative 4. Those are both going to be discontinuities for sure, right? How do we know if they're wholes or VAs? One of 2 ways. We either plug those values back into the numerator and see if we get 0. If we do, 0 over 0 means whole. If we don't, non-zero over 0 means VA. Or you could try to factor the top. If you wanted to factor the top, let's see if it works. It may not. Factors of negative 8 that add up to 2. How about x plus 4, x minus 2? Well, if you bring the denominator around then, that's x plus 4, x plus 6. Notice the other way to know if there's a whole is do the x plus 4's divide out? Yes. So we now know that there is a whole. You can just sit on my desk, Elijah. There's a whole at x equals negative 4, and because the x plus 6 is not dividing out, there's a VA at x equals negative 6. So you can get rid of answer choice A because that has a positive 4. Great. Now we got a 1 in 4 chance of guessing correctly. But remember, we don't want to guess. The function f of x looks exactly like now whatever's left in the problem. X minus 2 over x plus 6, except x can equal negative 4. But remember what we did. We used what was left to find the y value of the whole. Because x minus 2 over x plus 6 paves right over the whole. So its y value is the y value of the whole before someone took it away. So what do you get when you plug a negative 4 in? You get negative 6 over 2, which is negative 3. So there is a whole at negative 4, negative 3. F as a whole and negative 4, negative 3. You factor, you divide out, and you plug that x value back into what is left. So there are all 9 multiple choice questions. Rework every question that you missed. Write a short little sentence on why you missed it. And be honest with yourself. Be honest with me. I want to know. I'm trying to assess what it is the deficiency is. It may not be a math deficiency. It may be an effort deficiency. It may be a caring deficiency. It may be, some extenuating circumstance in the home that I don't know about. I want to know. That's my job, to help you grow, to push you. But you have to help me help you, and you also have to help yourself. All right, let's do the free response. We got some time. I'm going to point out the proper way to do it and the common mistakes. So we have 3 functions, f, g, and h, and we need to answer the following questions. Well, the first thing you could do is to say f of blob equals the square root of blob plus 5 minus 4. G of blob is equal to the square root of negative blob plus 9. And then the last one could be h of blob equals blob squared minus 2 blob minus 15. Remember, we did that like on day 1. I told you that's what you could do to help yourself plug in the functions correctly so that you don't miss distributing negatives. All right, now you don't have to do that. Maybe you're advanced and you don't have to do that. Let's read this. It says, set up and then simplify the equation. A lot of people were not writing equations, but expressions for k of x equals g of h of x. So we're plugging h into g. And then find the domain of k of x by sketching the graph of your radicand. And here's a little note. I didn't have to say this. Be careful to use parentheses when substituting it for x so that you can distribute any necessary values. Show your work, including the graph that leads to your answer. Give your domain correctly. All right, there's a lot of words there. So here's what I'm going to do. I'm going to start off by saying just k of x equals g of h of x. Do I have an equation? Yes, it's k of x equals. Now you can work straight down without rewriting k of x. We're going to plug h into g. So here's the g function. The outer function is the square root of negative blob plus 9. And what am I plugging in for the parentheses? H of x, which is x squared minus 2x minus 15. That is your setup. If you don't have that, you're probably not going to get the answers right. Now, if you want, you could also just keep bringing k of x down, or just keep lining up your equal sign. A lot of people did not have equal signs equals k of x. We didn't take off on this test, but we will in the future. Did you ever kind of wonder why equation was in bold? It needs to be an equation, okay? And I named it for you. All right, so now you can, let's find the domain, okay? I told y'all to not simplify first, so you could go ahead and just say this entire thing here, plus 9 has to be greater than or equal to 0. Well, let's distribute. Negative x squared plus 2x plus 15 plus 9 has to be greater than or equal to 0. So that's negative x squared plus 2x. That gives you plus 24 has to be greater than or equal to 0. All right, that's a quadratic inequality, which means we have to solve it how? Graphically. That opens downward because the leading coefficient is negative. So there's two ways to do it. Method 1, factor out the negative first. We did this in class. If you have a negative leading coefficient, it's going to be more challenging to factor. Factor the negative out first, okay, and then change all the signs. And now that factors a little easier. That's x, minus 6 times x plus 4. And again, if you're not sure if that's right, you can FOIL it, right? How many times do you get to check your answer before you turn it in? You can FOIL it and make sure you get that. A lot of people had it factored wrong, and I guarantee they didn't do FOIL to check to see if it was the correct factorization. So now that's enough to sketch your parabola. The roots are positive 6 and negative 4. And because the coefficient is negative, it opens downward. And now you want to know for what values of x is it greater than or equal to 0? That's going to be on or above the x-axis. That is actually between negative 4 and 6. So remember, this is your compound inequality. This is the AND case. X is both bigger than negative 4 and less than 6 at the same time. And so if you put your x up there where the shaded is, you can write your domain using that as a template. D sub k colon is the set of all x such that negative 4, x, 6, right? You see that? X is physically between negative 4 and 6. And for the AND case, which is the only time you should be using compound inequalities, they're always less thans or less than or equal to's. Less than or equal to's in this case because we can hit the x-axis. You should never write a compound inequality with greater than symbols in there. Okay? And it should always be from least to greatest. Because the other case is the disjoint set, which is the OR case, and it's two separate intervals, two separate inequalities. Okay? Or you could write it like this. You could say negative infinity to negative 4 with a bracket. Oops, sorry, that's the other way. My bad. That would just be from negative 4 to 6, like that. So you could have done it like that. But if you factored it wrong, you're using the wrong values. So I gave a check just for the parabola. Just for the parabola, any parabola. You could have opened up or down. Some people didn't graph parabolas. The other way to do it, here's the other way to do it. Okay, and some people did it like this. You could just multiply all the way through by a negative. That still changes the signs, but what does it do to the inequality now when you multiply both sides by a negative? It flips it. So now it still factors in the x minus 6, x plus 4, but now it's less than or equal to 0, and now your roots are still negative 4 and 6, but it opens up now, and now we want to know where is it less than or equal to 0. Well, that's going to be now below. And surprise, surprise, or not really, it's still going to be the AND case. So you still get the same inequality. We worked it like that both ways in class. Okay, so both methods are correct. But remember, if you factor the negative out, you need to keep it in front all the way down. And notice, I never said each factor greater than or equal to 0. you would lose points for that. As long as it's fully intact, you could still say it's greater than or equal to 0 because you're not breaking the algebraic rules. You're sketching the graph. All right, so then you got 1 check for the final answer. And it had to be spot on with the notation and everything. So some people got the 1 out of 2 checks there because they had a parabola. There's the first check. Here's the second check. All right, the next one. Set up the equation for r of x. And again, equation is in bold. So here we go. R of x is 2x minus 10. I gave that to you. All over h of x, which again is x squared minus 2x minus 15. We did a lot of this early on. We quizzed over it. You're trying to find the discontinuities. Label them, tell me where they are and what they are. All right, so again, you have a rational function. There's no radical. This is an option. You could say x squared minus 2x minus 15 cannot equal 0. You're working with your denominator. That gives you, let's see, x minus 5, x plus 3 cannot equal 0. So you know the domain of R, which I didn't really ask for, is the set of all x such that x cannot equal positive 5 and negative 3. So remember, those are your two discontinuities. Anything that gives you division by 0 is a discontinuity. And because this is a polynomial over a polynomial, they're either wholes or vertical asymptotes. And again, there's two ways to tell. You can either plug your 5 and negative 3 into the numerator. If you get 0 over 0, it's a whole. If you get non-zero over 0, it's a VA. So what do you get when you plug a 5 into the numerator? 2 times 5 is 10. 10 minus 10 is 0. So when you plug in a 5, you get 0 over 0, which means there's a whole at 5. What do you get when you plug in a 3? You get negative 6 minus 10. That's negative 16 over 0. You know there's a VA at negative 3. That's one way to do it. That's one way to do it. But because now you know there's a whole, now we're going to have to factor the top and bottom. Some people wrote on their test, the top does not factor. It does. What is the first rule of factoring? Look for a what? Common factor. And we have a common factor of 2. Or realize if you plugged a 5 in to a polynomial and got 0, x minus that number, x minus 5, is a factor. So that factors into that, and the bottom, of course, factors into this. So notice how I'm rewriting the function. I factored it over here for the denominator, which I did not have to do this. That's just one approach you could have. You could have just gone straight to this factorization. I did not ask for the domain. And now the x minus 5s divide out. So let's go ahead and say then that R, in a complete sentence, R has a whole at, the ordered pair is 5, and you got to check for that. If you just said a whole at x equals 5, you got to check for that. How do we find the y value for the second time on the test? Plug it into everything that's left. We're left with 2 over x plus 3. When you plug in a 5 for x, you get 2 over 8, which I did give credit for that, believe it or not. I'd like for you to simplify. So that's equal to 5 comma a fourth. So the y value for the whole was the fourth check. The y value for the whole was the fourth check. Some people forgot about the other discontinuity. What other discontinuity do we have? Negative 3, yes. R has a, and I'll let you abbreviate VA at the equation x equals negative 3. That's your fifth check. It was amazing how many people only found one but not both. Okay? Remember, any value that makes the denominator 0, we had 2 of them, that was a quadratic, is going to be a discontinuity. It's either a whole or a VA. Right? There you go. So that's how you do that one there. And that's all I really needed to see. And again, notice my notation is spot on. I didn't have to do this denominator work. If this was all that I showed, that's enough. R of x equals, R of x equals. I'm working with an equation. I'm working straight down. All right, part C. Set up the equation for j of x. All right, so j of x is h of x again, which is x squared minus 2x minus 15. All over, for the first time, we have f of x, which is x plus 5 minus 4. All right, so now we need to find the domain. The numerator, we don't care about the numerator here. It doesn't affect the domain. So we have the radicand, which is x plus 5 is greater than or equal to 0. So x is greater than or equal to negative 5. We have the denominator, which is this, cannot equal 0. Here again is where some people just drop they drop that radical and said it's that. What kind of math are you doing? That doesn't work. It's never worked. Okay, if you square it now, you're going to have an ugly mess. You have to isolate the radical. Now when you square the left side, you get x plus 5. Some people did not square the right side. They left it as 4. But you got to square both sides. Is it okay to write squared on both sides like that? Yes. That raises the blue flag now. 4 squared is 16. So you subtract 5, you get x cannot equal 11. All right, you try it out. We're saying 11 causes 0. 11 plus 5 is 16. The square root of 16 is 4. And 4 minus 4 is 0. So he is not extraneous. He does cause a 0, and he is greater than negative 5. So now we just write the domain. D sub j, the set of all x, such that x is greater than or equal to negative 5, comma, or whatever, x is not equal to 11. That would also be beefy bracket negative 5, comma 11, stepping over it, going to infinity. So if you missed that one, this was the most correctly gotten question on the back, okay? But if you got negative 1 or something for the x, you did your algebra wrong. All right, then the last one here. This is the one that you're going to be working for homework if you miss anything. And you should get this one correct from here on out. Minus 2x minus 15. All right, so some people are still setting up the first term wrong. We are plugging in for x that. So if you want to put brackets here, that's going to be blob squared minus 2 blob minus 15. And we are plugging in x plus w, x plus w. If you can't do that, you need to practice 9 times, okay, for the homework. Minus parentheses or brackets. Believe it or not, some people are still missing that parentheses. They are still missing that parentheses all over w. That would be your first check. That's your 8th check. By the way, these were worth 1 check apiece. Some people are missing that step, okay? If you want to have this in brackets as well, that's fine to show the first term, but you really need them on the second. That's the first check. All right, now we expand. Square the first, multiply and double, and square the last. There. Distribute the negative 2, negative 2x minus 2w. You're not just distributing the 2, you're distributing the negative as well, right, Zach? I think that was yours, right? We distribute the negative 2. Did you? Okay, I thought you were the one that only distributed the positive. Oh, you were the, okay, yeah. Gotcha. Okay. All right, well, cool. Then, good, yeah. So, right, Zach? Heck yeah, Mr. Corby. Sorry. Minus x squared plus 2x plus 15. Does it matter if we put it over w here, or can we just hold off on that to the end? No, you got to put it over w. Here's your checkpoint. If you did it correctly, they should cancel. Oh, guess what I forgot in my haste right here? And some people did that. Right there, that should be a minus 15. I distributed the negative 2, negative 2x minus 2w minus 15, and then distribute. Whew, good thing I'm on my checkpoint here. The 15s cancel, your 2x's cancel, your x squareds cancel. And you're left with this, 2xw plus w squared minus 2w all over w. Now, some people get real ugly with their dividing out. I want you to show the step. I want you to show the step. I want you to show this step where you're dividing out your w's. Factor it out, divide it out. You're left with 2x plus w minus 2. There's your 9th and final check. Here's a common error that I saw. I saw a lot of people factoring out the w like that, but then they still left it on the inside. Is that correct? You have an extra w. If you're factoring it out, it should be gone from the inside. That could lose the check. These will be in the shared folder. Watch it. Corrections due tomorrow. Those extra problems from my favorite problem due tomorrow. We're quizzing tomorrow on my favorite problem. If you got 1 out of 2 checks, work the 17, 16, 15 once. If you got both checks wrong, Then you're going to work each of them 3 times for 9 problems total. All right, have a great day.